In this section, we are going to write our first Go application. We'll end up with a full working example, and we're going to start from a simple hello world, and then we're going to build up until we have this full working example. I'm first going to cover command line arguments, and then we're going to make API calls. API calls from a Golang program are often used, so that's why I picked this as a first example for our first application. We're going to do JSON parsing because our test server that we're going to use is going to reply JSON. I'm going to explain you about functions, custom error handling. I will then explain you the flag package. We're going to do a post request. So first we did a get request, then I will do a post request. I will do some explaining about JWT authentication and how you implement that in Go. Then we're going to package our code, test our code, and then we will have a full working example that will be our first Go application. So quite soon, in one of the first lectures, we're going to start to build our HTTP client. This HTTP GET client on the left is what we are going to build, and it's going to make a connection to our test server. And this test server is not something we're going to focus on now. It's going to be pre-built. We're just going to start it. It's going to be an API server that's going to respond with JSON JavaScript objects. We are going to invoke GET requests to the test server endpoints, and we will get JSON objects back that we will need to parse. Then we will also investigate how we do post requests. We will need to do a post request on a login endpoint to receive a token, a JWT token, that we will then need to access protected APIs. So what I try to do with this HTTP GET client is to give you a nice example of invoking APIs, as this is the foundation of what you need to know to build applications that will interact with external APIs. Later on, when we will be using SDKs in Go, you will see that they will make these API calls for us. So when we are going to interact with an external system, it is often going to be an HTTP API call to connect to an external service. So learning how you make requests and how you can parse JSON objects or any other structure that an API would give us back is for me the first big step in learning how to use Golang in a cloud or cloud native environment. Let's start with our first Golang project. I opened Visual Studio Code, and this is the welcome page that opens. And I'm going to create or open a folder. And in that folder, I'm going to create our first Golang program. So here you can start with open, or you can use file, open folder. That should be the same where you click. We just have to open a folder, and that folder is going to be our project folder. I have a folder Golang demos that is empty. I'm going to use this folder to create my demos in. So I'm going to click new folder, hello world. I'm going to call this new folder. I am now in hello world, and I'm going to open this folder. So whenever I create a new file in Visual Studio Code, it will appear in this hello world folder. This is my hello world project. So I can click here on create new file, or I can right click new file. And the first file I'm going to call main.go. And this main.go is going to have our main function. It doesn't really matter what you give as a file name for your first program. What determines how it's going to be executed is going to be the name of the first function, which is always called main, if you want to execute an executable. So this is our main.go, and this is going to be an executable. That means that we are going to be able to run this. Later on, we will also create libraries. So libraries are not standalone. They also need other Golang code to be able to use those libraries. And this is not going to be a library. It's going to be an executable. So once we write our code, we can then execute this program, and it's going to output something. When in Visual Studio Code, it shows red. That means that there is a mistake somewhere. If you hover over it, it says expected semicolon, and found end of file. That means that we have to still write something to make sure that this Golang file is going to compile. Once it is compiled, we can then execute it. So let's write a little bit of code, the simplest code that we can write to execute a program, just printing something on the screen, and then we can compile it and then run it. If you are going to write an executable, it always needs to be in the main package. So we first have to define what package we are going to use. We can see a package as a grouping of Go files. So this package is going to be called main. Package main. And you see the red color is already gone. I'm going to save this. And this is actually what Golang requires. It requires that the first line is a package definition, package main. If you want to execute this file in an executable, Golang is going to look for the function main. So let's try to write this function main. If you want to write a function, we type func, func, from the word function, a space, and then the name of the function. If you're going to use the function main, then when we execute this file, this is the function that's going to be executed. We have two brackets after the main because there's no parameters that we're going to pass to this function. This function doesn't require any parameters. And then to define the start and the stop of this function, we're going to use curly brackets. One curly bracket after the main function and then one to stop it. We can save this. And this is actually our first Golang program that should be able to be executable, but it's not going to do anything because we haven't written anything in between. How do we execute it? In Visual Studio Code, we can open a new terminal. The new terminal will open in the directory that we specified, the helloworld directory. We should have Golang installed. So if I type Go version, I have Go 1.18.1. If I want to compile Go in a terminal, so with commands, we can also execute it in Visual Studio Code, but I prefer to execute it always within a terminal. I find that is easier. Go build main.go. Now it has been built. On Windows, you will have to type dir. Here on macOS or Linux, you can type ls. Now we have a main executable, which we can execute. So on Windows, you would just type main, and on Linux or Mac, you can type /main, and then this program will execute. It doesn't give any output because there's no output. We haven't written anything yet. So let's try to write something in this main function so that if we build it and execute it, that we will see some output. So there's actually a shortcut when you are developing. Instead of using go build main go and then main, you can also do go run main.go. And that will just compile it and execute it immediately. And then you don't have to enter the two commands. So that's what I will be using. If you want, you can also run it here, start debugging or run without debugging within Visual Studio Code. But I will use the terminal because I find it a bit easier. So in our main package, we have the main function. And then let's try to write our first line of Golang. If you want to print something on the screen, there's a package fmt. This fmt package is provided by Golang itself. It's not an external dependency, it's an internal dependency. So it will always be provided within the language itself. So if you type fmt, then now we can start using functions of this fmt package. And it will automatically be imported by Visual Studio Code once we start doing that. So if you want to use functions from another package, you need to import it, but you typically don't have to write the import lines in Visual Studio Code because it will do that for you. So if you type fmt and then a dot, we will see the functions that are available for us. And if you just want to print something on the screen, we can use printf or println to message something on the screen. And you see what happened here. Once I selected println, then it adds this import FMT. So now we can use the FMT package, and in the FMT package, we can use functions. Println is a function, print line, and FMT is the package, and the separator is a dot. So you will always see that once you want to use a function from another package, you just enter package name dot function name, and then you can use this function. So it's a function, so we're going to have to add brackets. If you want to know how we can use this function, we can hover over the function name and it will explain what it does. Println formats using the default formats for its operands and writes to the standard output. So it writes to the standard output. Within this function, it expects any kind of variable. So we're going to pass a string. In Golang, a string is denoted by quotes, double quotes, hello world. I'm going to save this, and then it's going to print hello world. And because it's print line, it's going to add a return after that, so we don't have to do that ourselves. Go run main.go, hello world. So this is our first Golang program that just prints something very simple on the standard output using the FMT package. So if you rather like to execute something within Visual Studio Code itself, you can go to run without debugging, and then it actually says that you need a Go mod file. So you need a Go mod file, which is the module file which manages the dependencies, which we haven't created yet, but it's very easy to create. So if you want to use the built-in functionality of Visual Studio Code, we can do Go mod init, and we can give our demo a package name, for example, hello world. And now we have go mod here, and it says if you do go mod tidy, it will also check all the module requirements and download the necessary external modules. We don't have any external modules, so let's try to just do a run without debugging again. And then it also outputs hello world. And what has been created is just then this file, this go mod file. This is our module hello world go 1.18. You can still run go mod tidy, but it's not going to do anything because we don't have any external dependencies at this time. I'll come back to this later on when we're going to have external dependencies. Now we can just ignore this go mod file. In my demos in GitHub, you will also see that I have this go mod file everywhere defined so that you can run always the demos in Visual Studio Code. So that is it for our simple hello world Golang application. Let's have a look at another package to see how we can pass arguments to our executable. So if we want to pass arguments, we want to do a go run main.go, and we want to, for example, pass argument 1. So if you pass this argument, it still gives hello world, but now we want to capture this argument and just output it. So to capture arguments, we need another package, the OS package. So before we print our output, we want to say our arguments equals OS args. And args hold the command line arguments starting with the program name. And it returns from this operating system package a string slice, which is the same as an array. So it's not just one string, it's multiple strings. We still get an error, 2 errors. The first error is because we don't have the OS name declared, because we also need to import it. So if you just hit save, then Visual Studio Code will import this for us. And then we have also args. Args is undeclared by the compiler, so we need to declare it first. And this needs to be of type string. So there's 2 ways in Golang to declare it. We can either say that we have this variable declared before we use it, like this, var args string, and then we can use it later on to assign it to args, and then we can print it. So now it still gives an error because we are not using it yet, but this is the first way of declaring and then using or assigning something to this args variable, which is a slice of strings. Or in Golang, it is actually also possible to not do this, but just add a colon in front of the equal sign, and then it will automatically declare this variable. So now the error that we have is it is declared but not used. So now it is declared. If it is the first time that you're using a variable, you can just use this colon sign, and then depending on what the variable on the right side will output, a string slice in this case, then Golang will declare it. So now we still need to output it. So what I'm going to do is I'm going to change this println in printf. And printf stands for format, so then I can format my string. So I say hello world, and then I'm going to add a return, \n is return, and I'm going to say arguments. And now I can format my string. So if you want to insert something in the string, you can use a %, and then S for a string, or you can use V just for the value, and then with V, then Golang, the printf function in Golang will decide itself what is going to output. So this is the default output, which is good in our case because we just want to output a string slice. We add another \n because we want another return at the end. And then we need to specify the variable that needs to be put in place here. So we can add another argument to this function, and we can say just output args. So args, the output of args will go right here, will be replaced and then outputted. Args contains all the command line arguments, including the starting with the program name. So the program name is going to be main. If the program executes successfully, it will be main and then the argument 1. So let's have a look. Go run main.go argument 1. So it says hello world, arguments, and then we have our main. So what go run does is it actually compiled it in a temporary directory. So this is a temporary directory. This is our main program name, and then we have our argument. So if we want to use this argument 1 in our program, how do we extract this second element in our string slice so they can use this in our program? We typically want to do something with all the arguments, not only the first argument. So if you would add another argument, argument 2, then we have the main, argument 1 and argument 2. And what we want to do is we want to make sure that we don't have the program name, but just our arguments. So then we can work with string slice functions. So this is a string slice of 3 elements now, and we can slice this up in different ways so that it only outputs the 2 last elements of this string slice. We can say as a second argument, so this is our OS args output, and then we only want to see the arguments. Then we can say I'm going to use args, which is a slice, and with square brackets you can denote what argument you want. So if you want to only show argument, if you only want to show the second element, then you can enter 1 because we start counting at 0. So 0 will be this argument, main, and then 1 will be argument 1 because we start counting from 0. I'm going to save this, execute it, and then you can see hello world. This is the full string slice, and if you just specify the second element with number 1, then we see argument 1 here. And I didn't add another enter, so that's why it looks a bit strange here. I'll add another enter. So this is argument 1. And you see there's no square brackets anymore around it because this is not a slice anymore, this is just a string. So when you specify one element, this is now a string. But we don't really want just one element. We want to see all the elements after are executable. So we want to see argument 1 and argument 2. We can say within Golang, when working with slices, 1 is my starting position. And if I add a colon, I can also specify the end position. The end position is going to be 1, 2, 3. So 3 is going to be the end position, which is also the length of the slice. So to know the length of a slice, you can use the function, the built-in function len. So if I say len args from 1 to len args, it will give me starting from 1, so not from 0, starting from 1, so it will start here, all the arguments after argument 1. So argument 1, argument 2, and if there's an argument 3, it will also add argument 3. Because with the input that I have here, it will be give me the slice elements, which will be another slice actually, not just one element, but another slice. Give me another slice starting from 1 to the end of this slice. So 1, which is this one, the length will be 2, so from 1 to 2, 1, 2. If we have 3 arguments, it will be 1 to 3, 1, 2, and then the third argument. But we can see that there is a recommendation here. The recommendation here in Visual Studio Code is actually to not put this one, because if we just remove this and we say from 1 to, and we leave the space empty, it will automatically go until the end. It will automatically take the length of the slice. So the easiest way to understand how to work with this is to just try it out yourself. So if I save this and do go run, then the arguments are now argument 1, argument 2. And if I do argument 3, if I add argument 3, it will show argument 1, 2, and 3. And if I then change it in another number from, for example, 1 to 2, and I execute argument 1, 2, and 3, I will only get argument 1 because it went from this 0, argument 1, start from here and end at element 2, but don't include element 2. So we stop here and we'll only get argument 1. If we change this to 3, then we get argument 1 and 2. And if we change this to the length, if we have 3 arguments, then the length will be 4. 1, 2, 3, 4. So if we would change this to 4, then we get argument 1, 2, and 3. But you have to be careful though, because we need to do some extra checks as well. And that I will explain in the next lecture. If we would say, give me argument 1, 2, 5, but don't include the 5th one, I actually get a slice bounce out of range error because we only have the capacity 4 and I'm asking for a range of 5, which means that I'm asking for something that's not there, and then Golang will throw an error. So to get used to how to work with slices in Golang, it's best to try it out yourself by changing these values a little bit and see what you get as output. Just remember that the first argument here is the starting point. The second argument here, the 5, is the end range, but it doesn't include the actual element. And we start counting from 0. So args 0 is the first element, args 1 the second element. So here we start from the second element. We go to the 5th element, but we don't include the 5th element. So play around with it a little bit, and then you will get used to how slices work. Then the last thing I want to explain is how do you run this within VS Code, within Visual Studio Code. So if you want to run args 1 to the end in VS Code, run without debugging. And then we have to go to the debug console. And then here we have hello world, the arguments, but the argument list is empty because we didn't pass any arguments. So how do we pass arguments? go run, and we can add a configuration. This will create the launch.json file within VS Code. And here you can then create your configurations. So here we have one configuration, launch package, go launch, and we should be able to add arguments right here. We put a comma on the last element here. So this is JSON, and then here you have args, and args is an array in JSON. If you want to pass one argument, we say argument 1. We save this back to our main, run without debugging, and then here we have now argument 1. So you can have your launch.json where you can define extra arguments, and then they will appear here in the debug console in the output when this program is executed. So when you want to pass arguments to your program, you can do that here. In the previous lecture, we just outputted our arguments, but what if we want to use a specific argument? So let's say we always want to use our first argument, which will be the second element. We refer to it as number 1, element 1, because we have element 0. So this is element 1, this is the first argument. So first argument is gonna be argument 1. So what if we execute our program with one argument? It will show our first argument. But what if we execute it with 0 arguments? We'll get a runtime error. So what we want to do is we want to avoid getting these runtime errors. If we want to for sure use our first argument to execute our program, we need to check on this because the index is out of range on this array. So this OS args is a string array, holds the command line arguments. First is our name of our program. So we want at least 2 elements. If you have more, that's okay. But if you have less, then we need to throw an error. So how do we check the length of our string array? We can use the len function. And here you will see the help of the len function. If you use the len function on an array, on a pointer, or on a slice, it will all be a little bit different. For example, if it's just a string, it will return the number of bytes. If it's an array or a slice, it will return the number of elements in this array or slice. And this is also a good time to explain the difference between an array and a slice. So we don't really have to do anything different in Golang to work with an array or with a slice, because it's all transparent for us, but there is actually a difference between an array and a slice. So when we are outputting everything of the string array here as from the second element, from argument 1 up till the end, that is a slice. So it's a dynamic view of an array. And that is the difference between a slice and an array. A slice can be of dynamic length. And that's what you should remember. Slices are always of dynamic length, whereas arrays are of static length. And you don't need to think about it much, because when you pass an array or a slice, it's passed in the same way. It is just sometimes that you have to take into account, for example, with the len function, that there is actually a difference between an array and a slice. And that will always be documented in those built-in functions. In general, you probably always use slices because the length of them are dynamic, and you don't really have to think about how many elements can there be maximum in this slice. So len args, if it's less than 2, we are going to return an error. We can say the usage of this program is helloworld. If we compile it, we will call it helloworld argument. New line, and then we can exit after this. If we want to exit, we can use OS exit, and then you can enter a code, which is an integer between 0 and 125. If you exit a program with error code 0, it was successful. Anything else is not successful. So we will say OS exit 1. It was not successful because we were missing an argument. I will save this. Go run main.go, usage hello world, and then the argument. Exit state is 1 because we added this line. If I type this, echo $, it will return the exit code of the last command. It is 1. So when we are scripting and we are executing a Golang program, and based on whether it was successful or not, we want to execute maybe something else, we can use this. We can use this exit code and we can say, okay, we need to stop now because this Golang program didn't execute properly if it was not returning 0. If we pass one argument, then the first argument will be argument 1. We didn't get an error because we checked on this. Echo $, will return 0 because it was successfully executed. We can still have more arguments. Argument 2 will also still execute because what I did here is I'm still passing this slice to my printf. The slice is representation of the second element to the end. Going to save this, and then in the next lecture we'll be able to use these lines of code because now we are sure that the first argument is passed because we are checking the length of the arguments, and we will not get an error anymore when we are going to use this first element as an input for our program. Before we stop with this lecture though, I still want to show you something. We have here args equals OS args, but how did this args actually get populated? How is it possible that we actually got these values in there? Because we're just assigning this variable to our own local variable here, but how come that this actually contains those arguments? So let's have a look. If we right click here, we go to definition, we will actually go into the OS package and have a look at the Golang code in this OS package. So here the args is declared in this OS package. And these packages, they also can have an init function. So we have the package OS, and here we have the init function. And this init function will be executed when we start using this OS package. And here in this init function, which is written by the Golang developers will then check, is our runtime Windows? If not, there's another init function for our Windows in exec Windows. If we are on Linux or Mac, like on our platform that I am on, then we're going to execute runtime args. And runtime args is then declared here. This is the signature of the function, but the actual content is in another package. It's in the runtime package. So when we are developing Golang, we don't really have to care that much about the runtime as long as we are not doing any system calls. But here they are doing some more tricks here than what we would just write as normal Golang code. So this is the proc.go. We can do the same with printf. So if you want to see the fmt printf function, then we can right click here as well. And then here we have the print.go that has a printf, sprintf, fprint, and other functions. You typically don't use it on the built-in packages, but if you have external packages, then you will see that to understand these external packages, you often have to look into the code. Not often, but it happens where you look into the code just to understand what they are actually doing in this package. So now we have our arguments. We are checking on the arguments. We need at least one argument. We can use this for our next demo. We can use this first argument, to supply some input to our program. In this demo, I will show you how to make an HTTP GET request. So we're going to run a server. I have a Golang server that we can start. And then we are basically going to write a client. We are going to make a connection to an HTTP server and just output what it returns. We're going to output the HTTP code and the HTTP body. And this is the first step to actually use APIs, external APIs, because if you want to use an external API, you will need to do HTTP requests or at least some kind of connection request and retrieve the data, parse the data, do something with the data, and then maybe make another connection request. So the easiest way to show this is to make an HTTP request and show the information on it. Then in the next demos, I will explain you how to parse the data and how to do the error handling and so on. So we can use this argument as our URL that we want to reach. So we can say we are going to write a program, HTTP get, we expect a URL, and then we're going to make a connection to this URL. If we don't get a URL, we'll throw this error, we will explain the usage. So what do we do? What is the first step is to make sure that the parameter passed is actually a URL, because if it is not, we should also throw an error. How do we validate whether it is an URL? We can use some Golang packages that have this functionality in it. How do you find these Golang packages? You can have a look on our website. You can just type in Google. You will find a Stack Overflow thread, or you will find some help documents that show you what is the easiest way to parse. But the first way in Golang to find something, to do something, should always be, is there an internal package? Is there a package provided by Golang that can actually satisfy my needs? And for us, because we just want to parse a URL, it is actually included in Golang. There is a URL package, and that URL package we will use to parse our potential URL that we are passing as an argument. So how do we do that? We just want to validate it, so we don't really need to do anything with the output. We just want to know whether it's a valid URL. So there's a package URL, and it has the parse request URI. Parse request URI parses a raw URL into a URL structure. If it is not a URL, it will return us an error code. So this is the function signature, func. This is how we use it, url.parseRequestURL. We pass a string, and it will return a URL type that is defined within this URL package, and an error if it cannot parse it. So while this is handy to receive this URL type that we can then use to get a part of the information out of it to, for example, see whether it's HTTP or HTTPS, we don't necessarily need this because we only want to validate whether it is a URL or not. So let's start with passing our string. So we're going to pass args and our second element within the array, which is number 1. And then this will then return the URL and the error. So we will say my URL, and then this is the error, equals this function. So in my URL, I will now have URL. And in this error, I will have an error. And I only want to check on this error. I don't really need this one. So if you don't need a variable, you can actually replace it by an underscore. So if I put an underscore here, I show to the compiler, to Golang, that I don't need this. You can just ignore this first argument. I'm only interested in this argument, the error argument. And if this error argument contains an error, then I want to stop the program. So what I can do is I could enter here and start a conditional, just like I did here. I can write if our error is not equals to nil, then it will contain an error, and then I will do something. But there is a shorter notation, and if you're checking on errors, it's very handy to use a shorter notation. I can say if, and then my statement. So first it will execute my statement, and then I use a semicolon, and then I can write my test. My test is going to be if my error is not equals to nil, which means that there is something in this error, then I will output the error and exit. So this error is of type error, and this error is basically just a string or empty. If it is empty, it will be equals to nil. So if it's not nil, it contains an error. And then I can say usage HTTP get URL. URL is in invalid format. and the actual error is a string of the error. So this will just output the error. So we can save this. So now at this point, we are sure that args, the second element of args is a valid URL, and we can then use this to do our HTTP request. How do we do an HTTP request? Well, Golang also has an HTTP package. HTTP, and then here we have all the functions we can use, including the get function. So this will do an HTTP get. We can have another look at the function signature. It accepts a URL, and then there's a response, and again an error that it is being returned. So we can pass the URL, which is still this one. We can also, if you want, assign a local variable that just says URL or hostname, and do hostname equals args1 so that you don't have to repeat this parameter. And then it will give us a response and an error. So again, we could wrap this into an if you want to. So we can say if and then semicolon, but then we actually will have an issue with variable scope, because if you do that, if response error, if error is not equals to nil, then right here, we are not able to use response. Response is actually undeclared, whereas here, response is declared. You see the error here is different. The error here is undeclared, and here it is like, okay, it's not used. So if you use an if and we declare our variables within the if, within the conditional, only within the conditional you can use the variables, and outside you cannot. So this can easily be changed by declaring it higher outside the conditional. And now here you can see variable of response is not used, but it is declared, so we can use it here. Depending on what you like most, to declare your variable here or to not use this shorter statement, you can actually just split it up like this again, and then your response will actually be scoped to the function and not just to the conditional. And to me, that's just an easier way of working. So we're going to do an HTTP get of our URL. It returns a response, which is of type HTTP response, and an error. Also, if you see this star in front of HTTP response, that means that we are getting a pointer back. I will have a separate lecture about pointers. In general, don't think about it too much. Just don't use pointers only when you need to use it. And right now, for our simple programs, we don't really need to use pointers, so we can just ignore it. If we have an error, we're going to quit our program. But we're going to quit our program in a different way, because it's not a user error, it's a system error. We actually want to see the error completely. So then you can use log fatal. Fatal is equivalent to print followed by call OS exit 1. So you could do it nicely and do an fmt printf, or you can just do this log fatal, which will exit our program, and we can just pass our error as a parameter. So you can do it either way. You can do it like this, or you can just do it like this. Why do I do it like this here and here different? Because we want to have more user-friendly errors here. So if the user does something wrong, we just want to have very user-friendly errors. You might want to have user-friendly errors here as well, but if we are just writing this program for ourselves, then log fatal error will do. Undeclared name log, we still need to save. Okay, and then log will be imported, and then we have no errors here anymore. Response will still show an error because we haven't used it. So if there is no error, response will have the HTTP status code, like 200 is okay, 404 is not found, 500 is server error, and so on. And it will also have the body. But the body is actually special. The body of the page can be bigger than our memory that we have available. So our body might not contain all the data from the HTTP output. So it's wrapped in a different variable, and that variable is a stream. Once our program exits, we need to make sure that we close that stream. And to do that, we can use another keyword that we haven't used before. It's called defer. Defer response body close. That means that once this function is finished, then at the end, our body, which is our HTTP body, it will be closed. So if you have a look at this explanation here, body represents the response body. The response body is streamed on demand as the body field is read. It's streamed on demand. So it doesn't contain all the information yet, because let's just imagine that we are downloading hundreds of megabytes of content. If it would all be downloaded instantly, then we would get an out of memory error. And that's why it is streamed and not all read at the same time. So that's why it's wrapped in a stream, and at the end of our program, we just have to close our stream. It's what you should do. It's to keep it all working correctly. So if you would have a different function, if you wouldn't have the main function, but a different function, then at the end of the function, it would close the body, because at that point, we don't need it anymore and we can close it. It's not going to immediately close it. It's because we use this defer keyword. Only here when we are at the end, it will then close this body. So now we can use this body. This body is streamed on demand, but we actually want to read all of it. Why do we want to read all of the body? Because we are actually working with very small outputs, JSON output often on HTTP calls. So if you know that everything fits in memory, you can just read it at once. We know that our JSON, our output, will fit in memory, so we can read it all at once. How do you read it all at once? There's another function built in Golang for that. It's called IO read all. Read all will read from a reader, from an IO reader. It is a stream and it will read until the end of file. So we can say read all, response body, and then response body, and then what does it output? It outputs bytes and an error. So we can say body error equals IO read all. We just test again whether we had an error, and if we have no error, we can now output our body. Our body is an array of bytes, so we still would have to transform this into a string, but there is a simple string function for that. Let's do fmt printf HTTP status code, which is going to be a number, so it's decimal, and then we can enter a new line, and our body is a string. Where is this HTTP status body? Also in the response, here we are using response body, but if you do response and we put a dot, we can see that there's other fields that we can use. You have the content length and the status code. So status code, it is an integer, that's why you use %d, and then we just need a body. Let's try to just use body. This is of byte. Let's save this. Let's do a return, and we ask output the body as a string. So let's go to my GitHub repository. So if you haven't cloned it yet, make sure that you clone it. My Git repository, Golang for DevOps course.git. Then we can go into this directory. And here we have the test server. Within this test server, we have the main.go. So we can just do go run main.go, or we can compile it. Or what I also typically do is I do a go run start.go, which will just run all the Golang programs. So if you split your main go out in multiple files, then it will load all the files. Go run main.go. This will start a server. And this starts a server on port 8080. And I will just open a second screen here. So now I have two terminals. So let's have a look at this main.go. It does a listen and serve of an HP server on 8080. And let's now do the go run of our main.go, which is the HP get file. Go run main.go, make sure it's saved. And let's see, what is the output going to be? Oh, I need to, of course, add an argument. That's the whole idea. So args1 is going to be my URL, HP, localhost 8080, and then there's a words endpoint that should return some JSON. And here we then have HTTP status code 200, and this is the body. The body is a string. So the conversion between the bytes, the byte array, and string is actually done by our printf function because we are using this string. In some cases, if you need to transform your byte array into a string, you can also use string. So if you for sure want a string, you can use a string function, and this will return a string. And this can be useful because sometimes it doesn't always know what to output if you have a byte array. Because if you say, I want to output a string, it will work, but I'm not 100% sure what it will do with the default value, because the default value is a byte. You see, so if I just change it now, you see, so it's actually the array of bytes. So this is how it looks. These are strings, these are letters, but they still need to be converted from bytes to strings. So if you convert it to a string, this should work, because now we are passing as an argument a string. Or you can say, I can pass the body as a array of bytes, but printf needs to convert it to a string. Status code 200. So if I would try some other endpoint, words, then I get status code 404, and then the body is 404 page not found. So this works. We are now making an HTTP call to our server with this HTTP get, this HTTP package. We get our response, our HTTP response, which has a body, which is being streamed, but we read all the data from our body, and then we output the body to the screen, which is just a JSON. In the next lecture, we will go over some more details, and then in the next demo, we can parse this JSON into a Golang variable, because now it's just a string, but we can actually parse this. So that's it. If you get any error, make sure that you don't have anything else running on port 8080. If so, you just might want to change this. You can also edit this main.go and change this port number if you already have something running on port 8080. So that's it. So our program is getting longer now, and we already start to do something useful. Let's continue with our HTTP GET demo. I changed the contrast a little bit of my Visual Studio Code. I hope this reads a little bit better than the previous lectures. I also made the text a little bit bigger, but I might have to make it a bit smaller again once we start working on bigger programs. We'll see. I think this is an improvement actually, so let's go with this. This is what we did in the previous lecture, HTTP GET of our URL. And we actually just outputted the body. %s, we output the body. But in general, we are going to want to parse the output. We're going to want to put it in Golang variables. And we haven't really talked a lot about variables. Okay, we have the error type, we have the body type, which is byte. We have these custom types here, like a URL. But we haven't really created any type ourselves to capture, for example, a JSON in. So let's have a look at what types we need to create to capture this JSON. I have still my test server. So let's run the test server again. And then let's run this words endpoint. So this is the JSON that we want to parse. We have a page, which is a string, an input that is a string, and the words is an array. And this is actually written in a way that we can add some words. We can have an input and we can add some words so that it displays in the JSON array words. We can also go to this hostname in the browser, and then we can add some words if you want. Or we can also just pass it here. We can pass an input variable. So our input can be word1. And then we have added word1 to the words, and our input is word. If we exit our test server, then it will be cleared again. So this is kept in memory. When we shut down our server, then it's going to be gone. So we can add more words in a separate window in a browser, or you can just do it here, whatever you find easiest. So this is what we would like to parse. So we want to create a type in Golang to parse this output. So we have first page, which is a string, input string, words, array of strings. Golang provides a type that is similar to objects in JavaScript that bundles together multiple different types, like multiple strings or a string in an array. And it's called a struct. So we can define a new type of variable using the keyword type. And we can call this words, and this type is going to be a struct. And in this struct, we can then define the attributes that we would like to see in this words struct. And it's going to be page, input, and words. So I'm going to write page, which is a string, input, which is also a string, and words, which is an array of strings. So now we can parse this JavaScript object into a Golang struct. And we should be able to then read exactly the page or the input, like words or word1 or a single element in the array. Because when it outputs, it's just a string. When we output this, right here, it's just a string, it's a body. We haven't parsed it into the smaller parts, into the attributes, the JSON attributes that we want to see. So this is a struct, but we don't really have a translation yet how a JSON attribute will translate to a Golang attribute within this struct. And in Golang, we can add metadata that then can be used by these packages that convert JSON strings to structs and structs to JSON strings. To add this metadata, we can use backticks. We can say JSON, if you're going to parse JSON, and those JSON libraries will exactly look for these keywords. We are looking for the JSON attribute page when we are going to parse this. And here with input, we're going to look for the input attribute. And with words, we're going to look for the words attribute. And now that we are going to convert this, when we are going to use this JSON library that's going to convert this string into this struct, this JSON library will look for this metadata. And when it sees page and it matches, it will take the value of that attribute and put it into our field, our struct field here. We map page, input, and words to our struct fields. So in Golang, we call these fields. We have one mistake here. I have a lowercase words here, and these are uppercases. And let's see what Golang has to say about this. Struct field words has JSON tag, but is not exported. So in Golang, when you use functions and when you use fields, and also with the types, you can export a field. So either you have a non-exported or an exported field, and this one is not exported. So with the JSON library, this will not work. The JSON library need exported fields. Otherwise, the JSON library, which is a different package, cannot access directly these fields. So we need to change our lowercase w in uppercase w. So we always need uppercases here, otherwise it's not going to work. If you forget it, then Visual Studio Code will alert you on this. And so normally it's a mistake that is easily caught. So now I have page input and words, and the first letter is an uppercase so that these fields are exported so that external packages can access our fields. So I'm going to save this. And then we only want to parse our data if our response code is 200. So let's remove this print line and let's first check our HTTP status code. If our response status code is not equal to 200, so this is an integer. So when we have an integer, we need to compare to an integer. So if you would compare against a string, it would not work. You see, you cannot compare mismatch types int and untyped string. So if you compare the status code, it's going to be without quotes, 200. If it's not 200, we want to print a message and exit. So I'm just going to copy paste this message and exit. Response status code is not 200, invalid output, HTTP code is the status code, and then we can print the body. We can convert the body to a string, or we can let printf convert it for us. If the status code is 200, we want to parse to this field words. So first we need to declare another variable. I will declare the variable words of type words. So this is type words, this is struct with the fields, and this is our variable that is declared but not used yet. Now I'm going to use a JSON package to unmarshal our JSON string into a Golang struct. Unmarshal parses the JSON encoded data and stores the result in the value pointed by v. If v is nil or not a pointer, it will return error. So we need a pointer. So when we need a pointer, the external package will explain to us you need to use a pointer. So then we just need to supply a reference to these words instead of just passing words. So JSON unmarshal, what is our data? It's our body, and then any type we can pass, but it needs to be a pointer. So we're going to reference words, and to reference we can use the ampersand sign. If I would not put it, again Visual Studio Code will alert me. You see it's underlined now. Call of unmarshal passes non-pointer as second argument. So that's why we have a reference to this variable, and then we basically pass the pointer and not just the argument. Unmarshal returns an error. Error equals JSON unmarshal. I don't need to put a colon here because we were using error earlier. So error will be already defined. We can just override it. So why do we have error here? So why do we have a colon here? Because body was not defined, error was defined, so you still need the colon here, but here we don't need a colon. If anything goes wrong, we can again do a log fatal. Now our words should contain the correct values. So I can now type fmt printf and output some of our words. JSON parsed, page, string, and I want to output all the words also as a string. And now I can say in my struct I have words.page. So page is going to be the field that's going to be inserted here, and then I'm going to do words.words, which is an array of strings. And I just actually want to return a string. So let me just change this in v, the default, and then it will just output for us a formatted array of strings. Let's test this out. go run main.go. I'm not going to pass an input now because we just want to see the same JSON output. What do we see? Parsed, JSON parsed, page is words, and the words is word1. You see, and it's actually the fmt printf of this value that puts these square brackets around it to print it. But let's say that we don't really like these square brackets and we just want to have a comma separated list of the words. Now we could actually parse this because now we have parsed the JSON and it's an array of strings. You have string functions in Golang in a string package, and you can join an array of strings together and provide a separator. So let's try to do that. Strings.join concatenates the elements of its first argument, the array of strings, to create a single string. And the separator we can then define is placed between the elements. So we're going to join, and our separator is going to be just a comma or a comma and a space to make it nice. And then we can save this. Visual Studio Code will import strings. We now have strings imported. And we're going to join this array of strings or this slice of strings. It always accepts slices and arrays, so you don't really have to worry about the difference. Let's try to run it again. But we only have one word, so it's not going to show. Let's add another word, word2. So now we see if you add another input, we have words is word1, word2, and we see it is comma separated. Word1, 2, and 3. So we actually parsed our JSON. This was our JSON. And now we have all the values available within a struct. We have 3 fields, and now we can do operations on these 3 fields. We can check the length, we can check the first element if it exists. We can use an input, we can use a page. So the first step when parsing JSON is to write a struct, and then you can use the unmarshal function. There's also a marshal function to do it the other way around. If you have a struct, you can also convert it to a JSON string. And of course, there's also tools that can help you convert JSON to a struct. So if you write in Google or any search engine, JSON to struct Golang as a search string, then you will find web pages where you can just copy paste JSON and it will give you this as output without the name of the variable, obviously, because the name I picked myself. So if you don't want to write it yourself, or if you have big JSON structs, then the easiest way to have these structs is to just use one of these tools and then copy paste it and then give it potentially better names if you want to give it a nice name. So I want to say just one last thing, that we now have used the string types, the string array types, and now this complex type struct is new, but you can obviously use different types here, different built-in types or different struct types as a field, and we'll have another lecture to go over more possibilities with some examples to show you other types that you can use, because these are just a few types that we have been using. In this lecture, I want to talk a little bit about interfaces. So if you go back to the demos and the code that I showed you in the previous lectures, I think I did a good job in explaining exactly what variables are returned, like a URL here, and how we are using these special types like a response, that you can actually have a response body within this type that you can then use, or that there are functions within this type that you can use to close it. But that doesn't really show you what is under the hood. I just told you you can use these variables like OS args, which are defined in a different package. But there is something missing here, something that I didn't explain yet, because we have this response body, and this response body is of read closer. And here we have a read all, and it expects an IO reader. So our types are actually different. Here we expect an IO reader, but we are passing a read closer. And if you have a look at our previous commands, for example, printf, we always first provide a string. So it's always a string type that we provide first. And then this is a second argument of the any type. So it can be an integer, it can be a string, it can be an array of strings. Printf will figure out for us how to parse it. And also you see the 3 dots in front of any. It's a slice of any. That means that this second parameter is optional and we can have 0 or more of those any parameters. Or here we have exit, which expects an int. Or here we have a string. Here we also have a string. So you see that in most of our functions, we pass a type that it expects. But here in read all, it expects an IO reader, but we are supplying an IO read closer. So let's have a look why this is possible. Why can we sometimes supply a different type to a function and that still works in Golang? And let's have a look at this streaming function, because this streaming function is actually quite important to understand how this works because it's so much used. So why don't we, in this lecture, write our own variable that we pass to read all, like a streaming variable where then read all will read all the data from. And then we will have an idea how this response body actually works. So I'm going to remove all these lines. We're going to keep the read all. And we're going to create another variable of a specific type, and we're going to pass that to the read all method. Also, this is going to be a little bit more advanced lecture, so don't worry if you don't immediately get it. This concept of interfaces will come back multiple times to fully understand it later on. So let's first have a look at this read all. If I right click here and I say go to definition, I will see the function signature. And here we are using this read all IO reader. So once we are in the IO package, it is not going to show this prefix IO reader anymore. So if we go here, it shows IO reader, but once we are in a package, it is just called reader. And this reader, this type, is defined within this OS package. So if I do right click and I go to the definition, I will go all the way up, line 83, and here this is defined. And this is a type interface. So we are not asking for a specific type like a string or array of strings. We are now asking for an interface. And what this interface means is that what you are supplying as a parameter to this function, it needs to have the function read. This function signature needs to be within that variable, needs to be available within that variable. So if we make our own variable that has within this variable, within this struct, if this struct has the function, and we didn't do this before yet, if this struct has the function read, then it satisfies our requirements to use this as a parameter, and then we can use it within this read all function. So let's try to go back to this read all function. It expects this reader, which is an interface, and our variable has the read function. So within this function, the only thing we can do with R is we can do r.read. And if you have a look, where is R used? Here R is used. So we can only do r.read. We can only execute this function read from this parameter R to then read the data. So to read all the data from the parameter that we supply, we can only use the read function. So if we build our own variable that we're going to pass, it just needs to have the read function, because that's what the interface says. The interface says, that is defined within this package, says you need to have the read function for every variable that you pass to this read all. And if that is satisfied, then you will not see an error. And within this function, we can then only access that particular function, because within read all, the only thing that we know is that this R has a read function. So let's try to implement that. And then we'll have our own reader where readall can read all the data from. So our implementation is just going to be a static string, because it's going to supply a string to our reader, and readall can then just read that string. With the implementation that we did in our previous demos, that was actually the HTTP call that was happening. So the HTTP call was happening, and then the endpoint would return some information like JSON, and then readall would read that information. So we are not going to make any connection. We're just going to supply a static string. So we don't need any of this anymore. We just need to have the readall. You can also just create a new project if you want to keep this code. And the code is also available on my GitHub repository. And once we have read the body, we can print it. Body or output. Body. Or we can maybe just call it out. And the parameter that we're going to supply is going to be our struct, a new struct. A struct that we still have to make. So I'll just keep this empty for now. So I will call this new struct that I'm going to create. I call it my slow reader. And why am I going to call this my slow reader? Because we are going to let the readall read one by one character by one. So it's going to be very slow, but it's going to be nice as an example. Type my slow reader is going to be a struct. What do I need in my struct? Well, I need to be able to supply a string, because that's a string that readall is going to read. So I'll just say contents. Contents is a string. How do I initiate a new variable with this type? I can do either this, var my slow reader instance, it's an instance. My slow reader is a type, and this is now a new instance. It's declared but not used. It declares an empty instance of the struct, but I don't really want to declare an empty instance. I actually want to define also the contents already. So there's another way to more easily declare it, and that is by using this notation, my slow reader instance equals my slow reader, and then I'm going to use a curly bracket, and then within this curly bracket I can provide values for the fields that are defined within the struct. So I can say my slow reader contents hello world, and I also need to supply a comma at the end because there can be other fields. So this is the contents field, this is my slow reader, this is a struct, this is an instance of the struct. So now I just have this struct with contents in there. And this my slow reader instance I'm going to pass to readall. Let me save. So now my imports that I previously had are gone. Now I have one error. My slow reader instance. Cannot use my slow reader instance, which is a variable of type my slow reader, as IO reader value in argument to IO readall. So I'm trying to execute readall. I need to provide a type of IO reader, but why can I not use this? My slow reader does not implement IO reader. So I need to implement this interface. I need to be having this read method, otherwise it's not going to work. It says missing method read. So this assignment, this passing this parameter will not work because I don't have this read method. Let's have a look again at this interface, the reader interface. So this is the function that I need. So every struct can contain fields, but it can also contain functions. So this struct, my slow reader, can also have a function. I can say func, and then I need to define that this function is linked to my struct, my slow reader. So I say m space my slow reader. And this m is then the variable that I can use within this function if I want to reach any of those fields within the struct. So m.contents, for example, will give me the contents of this field. func my slow reader, and then the function is going to be read, which is a copy paste of the interface function. Read will need one argument and returns an integer and an error. So there will be an error here, missing return. Let me just return something. If I am at the end of the file, and this is explained in the read all reads from R until an error or end of file and returns the data it read it. So if I just say, actually I didn't return any bytes because the first return argument will return how many bytes. I say there's nothing to return, 0. And I say IO end of file. So end of file is returned by read when no more input is available. If I use this and I save this, and let's try to test this out. Let's go to the helloworld directory. Actually, I'm still in my GitHub folder, so let me go to the helloworld. You can also just close your terminal and open your terminal if you don't know anymore where you are. So I'm in my helloworld project now, and then go run start go, output empty. So this actually ran, and what happened is it just returns 0 and end of file. So, but what is really happening here, we can actually use debugging in Golang. So if I put a breakpoint and I do run start debugging, then here I can use go inside function or just continue or skip to the next one to have a look what is really happening. So I put a breaking point at read all, and let's now go in this read all method. And then this is the R, this is a reader, but this is actually my struct that is being passed, my slow reader. And if I continue, oh, I went too far. It actually executes the read function. So let's start over. Let's restart, go inside this function. And when we hit the read function, let's go inside the read function. And then you see we are in our read function that we have written. It just returns end of file. So then it continues. Is there an error? Yes, it's not nil. Is the error end of file? Yes. Then return B, and B is our buffer where we put everything in, but our buffer is now empty because we didn't put anything in it. And then we output nothing. So our read function is executed, but we want to read the contents. And read will be executed until we say it's the end of file. So if you want to have a slow reading function and only read one character at a time, we can use built-in string slice functions in Golang to just return only one by one. But to return one by one the characters, we need to know where we are. So let's create another field, pos, of type integer, which is just a number. And using this field pos, we can store the position that we are. So the only thing that we need to do is we need to read the string contents, one character by one character, increment pos until we are at the end of the string. In other words, we can say only return something when pos is less than the length of the contents, because once our position is more than the length of the contents, then there's no characters left. So let's try to write that out. If pos is less than len contents, we're going to do something. Okay, we get two errors. Pos is not declared and contents is not declared, because they are in the struct, they are fields of the struct. And that's why we have this m, my slow reader. So this m refers to our instance of our struct. So if you want to access the fields, we say m.pos and m contents. There is still one problem. When we defined our pos, it starts counting at 0. So if you say if 0 is less or equal the length of a content, so if we have one character, it's going to execute, and then what we will do is mpos plus 1, so we can do plus plus, which is plus 1. Then the next iteration is going to be 1, and 1 is still equal to 1, so it will execute again, but there will be no more contents because our length is only 1. So we ideally only want to execute it once if there's only one letter in our contents. So if we say mpos plus 1, then for a length of 1, it will only execute once. It will only iterate once. If it's 2, then if it starts at 1, then 1 is less than 2, and then 2 is less than 2, so it will execute 2 times. So I think that's what we want. So an integer starts at 0, but actually it's easier for us if you just start at 1, and then we can compare it like this. The next step is to write data to this p variable. So if you have a look here, b is our buffer, and our buffer is passed to our read function, and in this buffer we can actually write our contents. And then this n is how many bytes have been read, and this error here is either end of file or an error. We can use to make a copy, to make a safe copy, the copy function. The copy built-in function copies elements from a source slice, this is our source slice, into a destination slice, and this is destination slice. As a special case, it also will copy bytes from a string to a slice of bytes. And that's what we need, this special case, because we have a string and we want to put it in a slice of bytes. And the slice of bytes is this one. And the output is an integer. Copy returns the number of elements copied. So that's what we need, because we need to return the number of elements copied and the error. So if we say n equals copy, destination is p, and our source, what is going to be our source? We want to copy one letter by one letter from the contents. So we can say contents, or m contents. And actually this will also work with a lowercase, so we can also have lowercases here, because we don't really need to export this. N equals copy m contents. Now we will copy the whole string, but we won't do it letter by letter because we have a slow reader. Where do we want to copy it from? From our position, which is 0 to start with. And what is going to be the end position? If you want only read one character by one character, it's going to be the position plus 1. So if you have 0 until 1, this will reply H. 1 to 2 is going to be 0, because we start counting from 0. 1 is E, and then 2 is L, but we don't include L, so it is going to be E. So that should work. And then we still have N declared but not used. Return N and nil. That should be it. Let's save this. Let's try to debug this first, because it's not going to work yet. There's still something that is not correct. But I want to show you that during the debugging, my slow reader instant read has been executed. We have P, which is an empty byte array, and then our position is going to be 0. Length of contents is not showing when I hover over it, but 0 is definitely smaller than the total length. So we can copy into P our age. Look, here's the first age. We increase the position and we return n. N is 1. One character age has been written into our buffer. So I'm just gonna hit continue now, and now we are the second position. And now there's something interesting that happened. So our M position is still 0, even though we increased it. And the reason behind this is that my slow reader is being executed again, and the contents, the changes that we made to the fields are not saved because we are passing it as a copy and not as a reference. So this is one of these use cases where you actually need pointers, and we are just going to say that this my slow reader here needs to be a pointer. So my slow reader, what we pass here is a pointer so that we can actually make changes. So M is a pointer to my slow reader struct and not a copy of the struct. And then here the implementation is now done as a pointer, so we also need to pass this as a pointer. So here we can say my slow reader, we add an ampersand here, this is a reference. And now this will be sent as a pointer. Whether you have to use an ampersand or a star, we'll have another lecture going into the details of that. But for now, here, this is now sent, this M is now a pointer. This my slow reader is now also sent as a reference because it's a referenced here. Let's try to execute it again. Run, start debugging. So this is the first execution, second execution. Now it's 1, now it's 2. And if you have a look here, now we add the L. Now we added the other L. And now the O. So we are just sending this back. So this is the buffer, but it doesn't send us the whole buffer that it already has. It just sends us a buffer that we can fill. So this P is always empty to start with, and then we just add the characters one by one to it. So if we just execute the whole thing, let's have a look, go run go, it actually outputs the hello world. So this is now a working program. In a real world scenario, this doesn't really make any sense because you wouldn't copy it character by character. You would copy as much as you can probably. So that's it for this lecture. We wrote our own streaming function. So this is how we implemented an interface, and we're able to pass our variable, which is a struct, with a function within our struct, so that we can pass this to read all, and then read all will invoke this read function. So this pattern of interfaces actually comes back a lot in Golang, and this is just a small example of how you can do this implementation, but you will see in other examples that this is going to come back.